All right, continuing on with two population proportions, we are going to move into an example of finding a confidence interval for the difference between two population proportions. And so we're going to stick with the same example we just did the hypothesis test for with the two different age groups for e-reader use. What we have up here is the formula for finding these confidence intervals by hand. I will go ahead and use that, but then I also am going to show you using the calculator, and as long as you can use it, the calculator will be okay. Okay, that's my main focus. So we're asked here to find a 98% confidence interval for the difference in proportions from the previous example. So first thing here, you'll notice that says that the confidence interval is going to be basically P1 hat. So P1, we'll use P, our young group, minus P2 hat, that's our older group. And then that interval is going to be created by both adding and subtracting this margin of error E, where here's the margin of error. So that's Z sub C, where C is our critical value. Basically, that's our Z sub alpha over 2, times the square root of P1 hat, Q1 hat over N1, plus P2 hat, Q2 hat over N2. Okay, so I tried to keep a copy of that previous problem up there so that you guys can still see it. The sample proportion of our young group that used the e-readers was 7%, so that's 0.07. And our sample proportion of the older group that used the e-readers was 11%. So we're going to take that difference, and then from that difference, we're going to both add and subtract our Z sub alpha over 2 value. Let me do that kind of off to the side over here. Alpha is 0.02, since we have a 98% confidence level. That means we want Z sub 0.02 over 2, which is Z sub 0.01. That's 2.33. And I'm assuming you know how to find those values by now. If you don't, you need to go back and review the previous chapters. And then we're going to multiply by the square root of, so P1, that was our young group, right? This was our old group. I'm sorry, our young group still. And then P2, these were all of our older groups, okay? So the proportion for our young group was, remember, 0.07. And then Q is 1 minus P, so that's the other 93%. And there were 628 of those. And then for our older group, we had 11% that used the e-readers. That means that 89% did not. And there were 2,309 of those, okay? So this difference, 0.07 minus 0.11, that gives us a negative 0.04. And if you do this other whole right-hand side in your calculator, you'll get 0.028. But I do want to show you how to do this on the calculator, okay? So I'm going to slide this up a little bit and put the calculator here, and we're going to go to Stat, and we're going to scroll over to Tests. And this time we want a 2 proportion Z interval. So that's option B. I'm going to hit enter. Because we just did this same hypothesis test, it automatically is populating the data there. So that's kind of handy. Remember, we had 44 successes out of 628 for our young group, and 254 successes out of 2,309 for our older group, and we want 98% as our confidence level. And so you'll notice here that it gives you the confidence interval there. So that is from negative 0.0681 to negative 0.0118. And so we can say, as a summary here, we are 98% confident that the proportion of people between 16 and 29 years old that use e-readers is 1.2% to 6.81% less than the proportion who use e-readers for ages 30 or more. So you can see here that because our confidence interval contained both negative values, what that tells us is that the percentage for that younger group was somewhere between 1.2, right, and 6.8% less than the proportion who use e-readers for the older group.